So this is example 2's video. We're going to talk about buttons and if statements. We're going to go through the example, and there's a couple key parts that we will talk about, such as what's an if statement, how do buttons work, a little bit of that. But again, there are some additional videos on those things. So before we get started, I'm again going to scroll through this kind of quick, but hopefully it's slow enough that you can pause the video and see something a little bit better if you don't have access to my OneNote. All right, so I'm going to be using Tinkercad to solve this. But remember that I'm encouraging everybody to use their actual Arduino and Arduino kit with all the components to build that. It's good to get that hands-on experience. All right, so what we want to do is we want to get a button to interact so that when I press buttons, certain things happen. We don't have a lot of practice yet with too many things, and so we're still going to be using LEDs. That's what we use for example 1, and we're just going to add buttons into this. So the first thing is what's an if statement? An if statement is a selection structure. So if I go back to example 0 really quick, we had some sequence, we had some structures, we had a sequence structure. We did that last time where we turned on an LED, waited, turned off, and waited. What I want to look at today is I want to look at our selection structures where I can select one path versus the other, or select one path and then skip something else. And so that's what we're doing. We're going to somehow be able to ask some type of question that can be checked so that we do one thing or the other, or this would be one thing or the other, or we do one thing or else we just skip something. All right, we're gonna have to have some type of condition in there, and we'll talk about the condition a little bit. The condition is gonna look something like this. There's gonna be some variable that has some value stored in it, and so button value is a variable, and it's gonna have some number stored inside of it. What this double equal sign does is it checks to see if those two things are equal. Is whatever is stored in button value, if that is equal to 0, then the condition is true, and whatever code I have within the scope of this if statement, by scope, I mean this code that's going to be between these curly brackets. If the condition's true, then the code between the curly brackets runs. If it's false, then we jump and we skip that code. Buttons are digital sensors. They're going to have two possible values, either pressed or unpressed. You can think of that lots of ways: yes or no, true or false, on or off, 0 or 1. And I'm going to need a few things to run that. First, I'm going to need a variable that's going to tell me where my button is connected, just like we did with our LED. But I'm also going to have a variable where I can store what the button is currently doing. Is it in its pressed state or is it in its unpressed state? And that is going to either have a 0 or a 1 in it, depending on if it's pressed or unpressed. Now be careful, the 0 and the 1 don't necessarily always mean the same thing. So 0 might mean pressed sometimes, it might mean unpressed sometimes. It really depends on the circuit. We have a new built-in function called digital read. The digital read function is we're going to read what's happening where the button's plugged in, and we're going to take whatever is happening there and we're going to assign it into my variable button value. I have two ways to hook up the buttons. This is the first way to hook up a button. And if you hook up the button this way, which is perfectly fine to do, when you do a pin mode, you're going to type in pin mode, and inside of it, you're going to put the pin. In this case, that would be pin 2. And then you would write the word input all capitalized. There's a second way to hook up a button. It's a much simpler way to hook up. By simple, I mean there's less wires and less things going on. This is how I hook up my buttons about 90% of the time, but if I hook it up this way, I have to change the code a little bit. And what I do is I do pin mode. I put in my pin, which again would be pin 2. But instead of just input, I put in input underscore pull up. And that allows me to hook up the button this way. So make sure that however you hook up the button, either way works just fine, but just make sure that you're using the proper pin mode. All right, so here is the example problem. Set up a circuit with 3 LEDs and 2 buttons. Use 3 if statements that do the following. If one of the buttons is pressed, the LEDs will cycle. What that means is the first LED turns on, then turns off, the second one turns on and then off, and the third one turns on. If the other button is pressed, we're going to have all of the LEDs turn on. If neither button's pressed, we're going to turn off all the LEDs. And as I said, if there were a homework, I would require this. I put this on here for this example, explain in the video why things do not work the way you planned. The reason I put that on this one is the way that I have it set up, sometimes things don't work out the way that maybe you'd think. And so you have to do a little bit of thinking on why things are happening the way they are. Maybe we'll talk about a couple of those things as we do this. All right, so I'm going to have this circuit. I've already built it in Tinkercad. We'll go over there in a second, but my circuit's going to look something like this. I have 5 components, 3 LEDs, 2 buttons. I have them hooked up a certain way. Let's see. In the planning stage, what I did this time was I kind of outlined what's going on. I say I have 3 LEDs. Those are digital outputs. They're going to be in these pins. I have 2 buttons. Those are digital inputs. They're in these pins. I'm using the input pull-up method. Here are the variables that are going to be global variables. They're going to be of a data type byte type. I'm going to have inside the loop scope, I'm going to have a state 1 that's going to store the value of button 1, a state 2, which is going to store the value of button 2. I'm going to have a delay time in the first if statement. That's going to be an int type. So I just kind of went through this. We'll talk about these as I write them in as well. I went through and I don't have my top-down design, but what I did was I still made a flow chart. So I'm going to read a button. I'm going to store the value. I'm going to read the second button. I'm going to store that value. And then I have some if statements where I have some branches. If something's true, we're going to do this. If it's false, we're going to check out the next one. We have a second if statement. If it's true, we're going to do something. If it's false, we're going to skip it. I have the last one, another if statement. If it's true, we do this. If it's false, we do this. And we're just going to continue on because this is a loop. All right, so let's jump into the code. I have this set up. I have my circuit set up. I have them all set up the same over here. And so the first thing I want to do is I want to, let's say this is a homework and you're like, you know what, this is a much more complicated than homework 1. There's a lot of stuff going on. I'm not even sure what to do. Well, let's just start with the very beginning. I have 5 components here. Digital components, they're all hooked up to the digital side of the board. Let's just make some variables for them. So I'm going to make some variables for each of these. I think that the red one was 13. Yes, it was. All right, so I'm going to just make my variables for now, and I might not know anything else to do except for that. That's better than nothing. That means that you do know something, and it means that if you have a question, we can at least have a starting point, and we're not starting at the very beginning. I also need to do the same thing for the buttons. So I have byte button 1 equals 2, and byte button 2 equals 3. I could add some comments in here. It might be a good idea for me to do that at some point. But I have my 5 components and I have my 5 global variables. These are all digital components. That should tell us something else. Each digital thing I need to set up that pin with a pin mode. So I'm going to go into the void setup and I'm going to do a pin mode for each of these. And I'm going to do some copying and pasting, which is perfectly fine because I'm just copying and pasting my own code. But you do have to be a little bit careful because I do have to go in and I have to make a few changes. I don't want to just set pin 13 as an output 3 different times. I want to make sure that I do each of those. I need a pin mode for my button, for actually each of my buttons. And because of the way I set this up, these are input underscore pull up. I'm going to copy that, change this to a 2. And at this point, it's like, all right, so I really just, I'm setting things up. To be honest, I still have no clue maybe what's going on, but at least you don't have a blank homework assignment. At this point, a lot of times what I'll do is I'm just going to start the simulation, or I'm going to run my code, because sometimes I make mistakes even up to this point. I misspell something, something's in the wrong spot, I forget a curly bracket or a semicolon or something. This is running. Obviously, I don't see anything happening because I haven't told it to do anything yet. But at least what I have, I've put 10 lines of code in here. At least those 10 lines of code don't have an error in them. I'm going to add one more thing in the setup. And again, there's videos about this, but I'm going to talk a little bit about it here. I'm going to type serial.begin 9600. Now, what is serial.begin? The S is the only thing that's capitalized here. What that's going to do is that is going to begin a connection between the Arduino and my computer. Then they can share information back and forth. Previously, what we were doing is we were just uploading the code, and the computer was nothing except for a battery giving power to the Arduino so that it kept running. If I have this serial.begin, they're actually going to be communicating while the code is running. And the reason I want to do that is because with the LED, if it wasn't working, it was kind of easy to see that the LED wasn't working, right? The light wasn't turning on. With a button, I can click it and I can hear it click, but I don't actually know whether it is reading that the button has been pressed or not. I can't see that. I can assume that it's being, that it should be working, but I don't know for a fact that it's working. So what I'm going to do is I'm going to print values to the screen, and we'll do that in a second, so that we can see what's going on. So the next thing I want to do is I want to read these buttons. So what I want to do is I need to make a variable and then save into it what the button is doing. I'm going to make a bool or Boolean type a variable. I'm going to call this one state1, and I'm going to do digital read button 1. All right, so what is this doing? I have this function called digital read, and I'm telling it to look at button 1. Button 1 is connected to digital pin 2. So if I click this button, it's going to read what's happening at this pin. It's going to say whether the button is pressed or not. And it's going to save that into state 1. Bool is a data type that can only save zeros and ones. So they're good for these things like buttons for our digital sensors. Next, I'm going to do the same thing for the other button. Bool state2 equals digital read button 2. Now, theoretically, these should be working fine. I can hit start simulation. I don't have any errors. And so I could assume that everything's good. But the problem is I can press this button, but do I know what's happening? Do I know what's actually going on? And the answer is I don't. I can really assume. I've done this multiple times, but I still am not positive what's happening until I actually see it. So after I take these readings, what I'm going to do is I'm going to type in serial dot print, and I'm going to type in the parentheses state 1. The only thing capitalized is the S in the serial. There's a dot print, and then inside the parentheses, I type the thing that I want to have print. I'm then going to type in serial dot print ln and type in state 2. Now, print and print ln do exactly the same thing, except for print ln will make a new line after it prints. So let me go ahead and start this. It seems like we made an error. I misspelled serial. There we go. Now, depending on whether you're using the Arduino software, Tinkercad, there's going to be different spots to do this, but you have to figure out how to open the serial monitor. And what I have is I have these two 1s next to each other. The reason I have two 1s is because I'm reading two things. Why are they next to each other? Well, state 1, I tell it to print it. And state 2, I say print it and then make a new line. So one of these columns is for button 1, one of them is for button 2. If I press this button, the first one turns to a 0. So that means the way I have it set up, if I press down the first button, it turns to 0. So 0 means pressed, 1 means unpressed. Let me check the other button. There we go. And because I can't touch both of those buttons at the same time, since this is a computer, I only have one little clicker here. If this were a real thing, you could use 2 fingers, press the buttons down. What I'm going to do here is on Tinkercad, I can hold shift when I click, and it's going to hold those pressed down. So I press both of them down. They're both reading 0. If I press one, it unclicks. If I press the other, it unclicks. So my buttons seem to be working. All right, so that's great. That's why I like serial prints, serial.begins, because I can actually see what's happening in memory. All right, so now let's say that you're still a little bit, I'm not sure what to do at this point. What we can do is we can go back and we can say, all right, let's look at what's being asked to do. Set up a circuit with 3 LEDs and 2 buttons. We're going to use 3 if statements. I can stop right there and say, okay, I can do that. Now, you might not know what to put in the if statements yet, but I can write an if with parentheses, open curly bracket, close curly bracket, and I can do 3 of those. There we go. I have made 3 if statements. Now, they're not complete yet. I don't have conditions in here, but I am a little further along than I'd be if I just said, I don't know. So I made 3 if statements. If we come back here, the first one, if one of the buttons pressed, so let's say if button 1 is pressed, it's going to turn on the first and wait. Then it's going to turn off the first and turn on the second and wait. Then it's going to turn off the second, turn on the third, and keep the third one on. So I can do that with pseudocode really quick. I'm just going to type in R for red, red on, wait, red off. Okay, so that turns the red one on, waits, turns it off. Now we're not going to wait again. We want the green one to turn on immediately afterwards. So no waiting, green on, wait, green off. And then I want to turn the blue one on, blue on. All right, even if you don't remember how to necessarily make this happen, write some type of pseudocode in here. Get something organized. For my second if statement, it was turn all of them on. Red on, green on, blue on. And for the last one, it was turn them all off. Red off, green off, and blue off. I'm further along than I would have been, even if I'm not sure. If this is how far you get on a homework, that's fine. Bring that to class, email me, talk to somebody else and say, look, I got stuck. This is what I have so far. What would be my next step? All right, there's one of two things I can do. I can either start figuring out what to put in here, or I can start figuring out what to put in here. Either figure out the condition or figure out the steps. Let's work with the condition first. The condition was if this button was pressed, if the first button was pressed. All right, so if we start the simulation real quick, I can't do that anymore. I actually have these if statements. And since they're not complete, I'm going to get an error. But that's why previously I checked out what was happening. And remember, if I pressed that first button, that was state 1, then I got a 0. When I didn't press it, I was getting a 1. So if I want to, button 1 is pressed. When button 1 is pressed, I get a 0. What I want to do is I want to write a condition, state 1 equals 0. What that does is it checks to see if these two things are the same. In memory, there's a spot called state 1 that has either a 0 or a 1 saved in it, depending on what the button was doing when it took that reading. It prints that to the screen so I can see it, but it's looking at it. If state 1 is 0, then this condition's true. If state 1 equals 1, then this condition's false, and it's going to jump over this and check the next one. Well, the next one was, what if the other button's pressed? Well, that would be state 2. If state 2 is equal to 0, remember the double equal sign is checking to see if those two things are true. The single equal sign sets a value, right? It assigns a value. The double equal sign checks to see if that is true. So we're going to check to see if this is true. If this is true, if state 2 is equal to 0, then both of these, or all three of these LEDs turn on. If not, we hop down here and we check the third one. The third one is if neither one is. State 1 is equal to 1, right? That means that it's unpressed. And state 2 is equal to 1. So if I have multiple conditions that I want to check in here, I have to write them each individually, and then I link them together with something such as an AND. To check if both of these are true, I put an AND. To check if one of the other is true, I use an OR. An OR would be 2 vertical lines, and that can be found on most keyboards, Shift, \, it's above the Enter key. And I can kind of play around with this and see which one works better for me. Let's keep it an OR right now just to see what's happening. All right, let's start the simulation. No errors, that's good. But at this point, I still can't see what's happening because I don't have anything going on inside of here. If I wanted to, I could serial.println and type in here, let's say first if statement. All right, so I'm printing something. And what am I printing? If I use quotation marks, what it's doing is it's going to print the words that are in here. So if we get to line 30, that means that we have to get inside of this if statement. It's going to print the word first if statement. When we're not in there yet because the first button is 0. If I press the second button, nothing changes. But what happens if I press the first button? If I press the first button, we should get into this first if statement, and it should print this onto the screen. If I let go, it stops printing to the screen because this is no longer true. All right, so that's something we can do. I'm actually going to delete that for now because what I want to do is I really want to focus on how to get this to work. How do I turn on my red LED? Digital right, LED R, comma, high. This is example 1 all over again. So if you have questions, go over example 1, homework 1. Wait, delay. I said I wanted a variable in here, and my variable was going to be called my delay time. That is a local variable. I'm going to go up here into this if statement. I'm going to make an int type data type. The variable is going to be called my delay time, and I'm going to set that equal to 1000. So all I did here was I made a variable. I don't need the parenthesis there. So that means this delay is now 1000. How do I turn R off? Digital right, LED R low. All right, I'm going to copy and paste some of this on here. I can copy and paste my wait. There we go. I'm also going to copy and paste turning things on. Oops. There we go. And I just have to make sure that I change this from red to green. To turn it off, copy and paste. I'm going to change that to green, and I'm going to change the high to low. And then I'm going to turn B on. All right, let's run it. Run things often, check to see if things are working. Nothing's happening, nothing's happening. It should only work when I press button 1. I press button 1, and things are working. This is where I was saying in your video, maybe explain what's going on. The red one doesn't seem to want to turn off. Even when I let go, the blue stays on forever. Maybe that's what you thought would happen, maybe you didn't. But again, talk about maybe why that's happening. Now, the reason why it's not happening is where in my code do I have a digital right LED blue low or an LED B low? I don't ever tell the blue one to turn off. That means it's going to stay on forever until I stop the simulation, which I did. That's why it finally turned off. All right, second one, second if statement. We're going to turn on, we'll turn on, and we'll turn on. And I'm just going to make sure that I turn on all 3 of them instead of just turning on the red one over and over. All right, so if I press this second button now, all of them should turn on. And when I let go, I'm not pressing it anymore, but they're staying on. Why are they staying on? Because I'm not telling them to turn off anywhere. All right, so in this last if statement, I'm going to tell them all to turn off. Now, what's happening is if either one of these buttons is not pressed, then it's going to jump into here and turn everything off. So if I hold down the first button, you'll see that the blue one barely looks like it turns on, like turns on and then turns off immediately. That's because this first if statement is true. And this second one's false, but this third one's also true. So this blue one turns on, it's on the last line of my first if statement, blue turns on, but then down here in line 52, I tell it to turn off. Happens almost instantaneously, we can barely see it. But now if I let go completely of everything, everything turns off. Because the only one that's true is this last one. This first one, nothing's turning on. This one, nothing's turning on. We just keep saying turn off, turn off, turn off, turn off. Now what happens if I hit the second button? It doesn't look like they're turning on all the way. The reason for this is, again, one button is pressed, which means they're turning on. One button is unpressed, which means they're turning off, and they're turning on and off so quick, it just looks like they're dim. There could be multiple ways to solve that, but maybe you're happy with that. Maybe that's what you meant to do. One way to solve that is in this second one, I could put a delay of like 10 milliseconds. Very, very short. That's shorter than the blink of an eye, much shorter than the blink of an eye. And if I start the simulation, that still means that this is on for significantly longer than it's off. Remember, computers, electronics, they move very, very fast. And so this is off for a fraction of a millisecond. This is going to be on for 10 milliseconds total. It's going to look much brighter. Technically, it is turning off every 10 milliseconds, but then it turns right back on for 10 milliseconds. It looks like it's just on all the time. I think that's the entire thing. Let's see. We have those, explain why things happen. We talked about that. We could add another one. We could say what happens if both buttons are pressed at the same time, or something like that. We're not going to make a second one. This video has been long enough so far, but I do want to go down to the very bottom and again show you what your homework submission would look like if this were homework. This time what I did was I made multiple folders in here. I have multiple codes. I'm not going to open up every single one of these, but I had 3 different versions of codes. If you have multiple versions of code, turn them all in, because I want to see everything that you did to make this homework work. Any documentation, any notes, anything like that, go ahead. Those are the ones that were in the OneNote, so I don't have to open those up to show you. And I have pictures. I am going to open up some of these images just to show you. It's sometimes very difficult from an image to see what's happening, so you might want to get different angles. And I also wanted to mention, sometimes depending on the buttons that we get in stock, they don't sit real well on the breadboard. And so sometimes when you do it, you say my button's not working. It could be a code thing. It could also just be the buttons aren't connecting well. You see that this button on the left isn't sitting in really well. That could cause it not to work very good. In this case, this one worked okay. And the reason for that, even though it's not plugged in over here on this close side, the far side is plugged in just fine. And that's where the wires are at. So it was working just fine, even though it looks a little weird. Lastly, videos. I made 3 videos. I'm not going to watch them. If you have access to my OneNote, you can come here, you can watch these videos. Why do I have 3 videos? Well, I had 3 different codes. I wanted to show how each code worked and what was different between each one. So that is what I'd expect for your homework. Everything you did for the homework, go ahead, put it in there, submit your folder to me, and I can look over it and make sure that everything's looking good.